Now we are studying here the algorithm for breadth first search. The breadth first search algorithm here capital BFS, which will accept a graph as the input. This graph contains vertex as well as edges. A set of vertex as well as set of edges. Now output of this will be a graph G with its vertices marked with consecutive integers in the order they are visited by the BFS traversal. It will return one integer array which will nothing but the order of the visited vertex. Initially, this algorithm is almost same as your DFS algorithm, but we have to apply here only the DFS algorithm instead of DFS. I have to apply here BFS. What is the use of this algorithm? Actually, these algorithms pick one element or one vertex from the graph and apply the BFS algorithm on that vertex and visit all the other adjacent vertices. Sometimes some nodes are not visited. In that case, it will pick the next node and try to visit again using the BFS algorithm. Like that, each and every node in the graph is checked for whether it is visited or not. That can be done by this algorithm, which is same as DFS in the previous example. For each vertex V in V do means we have a set of vertex. From this set of vertex, I have to take first vertex, check for the visibility or visibility. If there is no visibility, then apply the BFS. Like that, for each vertex, I am applying the BFS algorithm, which is not visited. In the next algorithm, I have created one BFS algorithm. Initially, the count is initialized to 0. First, the count becomes 1 here. Mark the first unvisited node with the count value, that is 1, and add this V and add this V to the queue. In the next step, we have one while loop. This while loop will be executed until the queue is empty. Once the queue is empty, our while loop stops and this DFS algorithms exit. In this while loop, we are using one for loop. This for loop take the adjacent node of that front vertex. To front vertex, what are the different adjacent nodes are there? That is nothing but W. Okay, take from the vertex V and check it whether that adjacent node is visited or not. Okay, if it is visited, it is marked with number. If it is not visited, then it is marked with 0. Then we have to check for the adjacent node which is not visited here. If it is not visited, we have to mark it with the number. Okay, here the incremented number is marked to the W, that is adjacent node. Once like that, we are adding all the vertices. In our example here, this is initially a V and these all are actually W here. The internal for loop just add these values like C, D and E. Okay, internal for loop just added this for loop to the here and mark it with the some number here. That is the job of this for loop. Once added the visited mark here, add that W to the queue here. Once all the adjacent nodes of the front vertex is added to the queue, we have to remove the front vertex from the queue and go to the next node from the queue. Take the next node from the queue and apply the same for loop again. Identify all the adjacent nodes from that, mark it, add it to the queue, remove the front vertex. This process continues until our queue becomes empty. Once the queue becomes empty, exit the BFS. Like that our algorithm works. Just like the depth first search, the breadth first search algorithm efficiency is also depending on the data structure we used for representing the graph. If the adjacency matrix we are using to represent graph, its efficiency is calculated as theta, the number of vertex square. So this symbol indicates the number of vertex in the graph. Okay, the time taken from here adjacency matrix is theta, the number of vertex square. If you use the adjacency list, its efficiency is calculated as big theta, the number of vertex plus the number of edges. When you total it, and that is nothing but theta, number of vertex plus number of edges. This is the efficiency for adjacency list.